Fun with planet movements. This is something that you may already know, but you've probably never seen it visually that clear. And this is the rotation rate and the size of the planet. We are comparing them. We start from the smallest of the asteroids and we go to the biggest member of the solar system. That is the local star called Sun. So we are tiny. Earth here was a sphere, but we accommodate also the people who believe in flat Earth. So we have a flat Earth version of that. So as you can see, everything is round except the Earth, which is flat, according to what you may like to believe. Some people may like to wind me up. So I wonder how they can do it now, because that Earth is flat. You can say the Sun is flat, but you see it is not flat. Or you can say it's a disk, who knows. Anyway, you need a lot of background if you want to convince me of that. This is the rotation rates of the planets. Again, you can see the slowest one is probably Venus and like Mercury, and the fastest one is the Saturn and Jupiter. And Earth and Mars are almost the same, and Uranus and Neptune are almost the same. The rate of the rotation of the Pluto, which is not a planet, is a dwarf planet, is a little bit slower than the Earth, but is in the same. Ceres, which is also a dwarf planet, or asteroid as we used to call them, is also rotating very fast, almost as fast as the Jupiter. Now the rate of the movements in the orbit, you can see the Moon is the fastest actually. We can call it a planet. Mercury is on the top, then Venus, and the slowest one is Neptune, which is, you can see that it takes around 180, 189 AU. That's the distance of the Earth to the Moon as a unit. It takes around 90 years or something like that. Sun to Earth, when the light from the Sun wants to reach the Earth, it has to go a long way. We know that is 8 minutes, light minutes actually. It takes 8 minutes to reach the Earth. And you can see the parcel of light is sent from the Sun. It has not reached, since I started to show it to you, the planet Mercury even yet. And now, with the speed of light, we can investigate the distance to the Moon. Its quickest is around 1 second to the Moon, 1.5 seconds to the Moon. The next closest planet takes a long while to reach to Mars. That's the communication between the Earth and the Mars. That takes time. I've split it again so you can see it. Any communication we send to the Mars rovers or Martian spacecrafts that we have there around in the orbit takes that long. If it goes any further, that will be even longer, to Jupiter and Saturn and other places. And this is quite I hope that you enjoyed these presentations. I like especially that flat Earth. Maybe it is flat, huh? Is it?